So our topic is SQL, and we've talked about SQL a little bit before, obviously, when we talked about how to use it to define a database. Now we're going to look at it specifically on how to query and work with data. So you're going to obviously, as part of your project, have to build a data schema. There isn't going to necessarily be a whole lot of data to put into it. There is some rules about different roles that should be there by default and things like that. But either way, going forward, you're going to need to know how to query using SQL, and this is a much more in-depth dive than we've done before. So we're going to kick off with a quick recap of what SQL is. I promise it'll be quick, just a few slides. We did touch on that already. Then we're going to dive right into simple queries. Then we're going to see how we can relate multiple relations and do what's called a join between them. We're going to look at subselects, and then we're going to look at kind of a little bit more in depth of join types, how we deal with different set logic, where you're just getting the intersection of the join, or you're getting the intersection plus one of the other sets. We'll look at that when we get down that road. So SQL, again, really quick recap. Remember, we pronounce the SQL. That's probably how you would phonetically spell that out. It's the language that we're going to use to manipulate and talk to relational databases, right? So it's important to note that, again, this is for relational databases. It is not necessarily the case that when we go to NoSQL databases, hence the name NoSQL, that we'll be using the same method to interact. In fact, there are some, I think I mentioned like Cassandra, that have their own like SQL-esque versions, like SQL with a C. QL for Cassandra query language, but generally speaking, you're not dealing in a relational database, so there's no reason to use SQL. SQL is primarily for a relational database. SQL stands for Structured Query Language, which we talked about as well, and remember that its capabilities are built upon the relational algebra that we studied, right? The current standard is SQL 2016. I'm not really too bent on you guys knowing like the dates and the standards, but it's good to know. And this is important, that most database management systems implement something close to this standard, but unfortunately there is not like this all-encompassing, I can write SQL for one database management system and know that it's going to work for any other. Like, that's just not the case, unfortunately. Usually you just need small tweaks, but it's just the world we live in. Now, one thing I do want to note, and I noted this before, the examples that I'm going to give, I've done in MySQL. So you can use them. I'm going to post them alongside these lectures and everything this week. So if you want to play along with these slides, you can do that using that SQL. If it's MySQL, it should work out of the box. If you're using something else, honestly, I think these queries are basic enough, they'll work. But it is possible that you'll have to make minor modifications based upon the database management system that you're using, because there's no all-encompassing gold standard that defines exactly how SQL works, unfortunately. So SQL is a very high-level programming language, and I don't remember if we really discussed this in depth before, but for those of you who have taken programming courses, you might have come across the declarative versus imperative programming paradigms. And declarative, remember, means you're saying what you want it to do, and imperative is really more of how you want it to do it. So SQL is extremely declarative. In fact, when I teach like SD2 or something like that, it's my favorite go-to example to contrast the difference, because in an imperative language you have a loop, right? And you go into the loop and you say exactly how many times this loop is going to iterate, whether it's to some number or the length of an array or whatever it is, and then you go into the loop and you compare each element of the array, say, to some value, and you decide like if that comparison is true, then you're going to output something on the screen, and you're going to show exactly how you're going to output it, whether there's going to be a box around it or lines or whatever. It's all completely up to you. You have to build it. SQL is not that, right? You just select star from users. Now we're going to see that work in a little while, right? That just means show me everything that's in the user table. You don't have to declare, you are declaring how many columns you want when you say star, like you're saying I want all of the columns, but you can just put star. You don't have to be specific about exactly which ones you want. You can be, and we'll see that. You don't have to say how to loop. You don't have to build a loop at all, right? It's all done under the covers for you. And that's what it means to be a declarative language. You say what you want the software to do rather than worrying about the implementation specific details of how it does it. So this is important with SQL because the database management system itself is where all those details happen. That's where we learn about what exactly takes place and deal with that is within the database management itself. Now, the trick there is that because this is abstracted away from you, you don't really have control over how that works, right? And we're going to look at this a little bit later with the amount of time different queries take. But because you're writing a declarative style, the performance of your query might be really, really good or it might be really, really bad. And because you're not writing the loop, you don't necessarily have control over how the actual database management system is going to take your SQL and implement it. Now, granted, there are rules of the road and there are some things that are generally better than others, but that said, you really need to optimize, and this is where the query optimization comes in, for your specific database in your specific database management system and your queries, right? You need to test your queries because it is completely plausible and possibly probable it's going to happen that a query run in one database management system like Oracle could have a completely different performance characteristic than that same query ran against the same data in another database management system, say like MySQL or something like that. So because of its declarative nature, you have to be cognizant of how your declarative high-level statements are actually implemented. It's very important. So quick recap again, we talked about data definition language when we declared how to create a schema, how to create relations, all that good stuff. And now we're going to be doing data manipulation language going forward. So everything that we're going to look at now is part of the DML or data manipulation language part. And that's what we're going to concentrate. So let's kind of dive in there. We're also going to be discussing this in the slides, and I'll get into the detail. And what I'm going to refer to as a generic query interface. The book also refers to it this way. And again, this is just that concept that because there are SQL standards and best practices, we can talk about queries in a general form, but it's not a promise that the actual implementation of a specific database management system will work with that generic query interface. One example of that is like when we talk about like inner joins, you'll see that the book will like be explicit and describe it as like inner join. But in reality, in a database management system, the word inner is not usually kept there, just join, and join implies the inner. So there's random stuff like that, but it's not that bad. The generic query that we have is most likely going to work in an implementation specific setting, or it's at least very close. So I'll try to point out the major ones as I go. There's no way I could touch on all of them, but I just wanted to say that here. Also, do remember that some of the specific examples I give later when we get into joins, especially in subqueries, I give a lot of specific examples. Those are written to MySQL, so they're pretty generic. They should work pretty much anywhere, but again, just keep that in mind. So a simple query. What is a simple query? So we're going to start by just using one relation, and we're going to see how to get some data from it. So we're going to do this with something called the select statement. And the select statement basically asks for tuples that satisfy some condition. So remember, the tuples are our rows, and we're going to use the select to say, hey, I care about tuples where, like, say the first name attribute of the tuple is Brian, and I only want to get those. So, you got a million rows in your database, whatever it is, and statistically speaking, out of those million rows, let's say, like, I have no idea, like 10,000 of them have the first name Brian. So you're going to return, if that's the only criteria you had, you're going to have this kind of view or sub kind of view of your relation that shows those 10,000 tuples as opposed to the original million, right? So it's analogous to the selection relational algebra, and it's broken up into three main keywords. Those keywords are select, where we're going to add the desired attributes. When I was doing, kind of select star before and just kind of rolling that out, I was referring to having all the attributes, right? But you can specify them, and we'll see that in a moment. The from is where you specify which relations you want to use. Now, we're going to start out with one, but in the near future, we're going to be combining relations so we can get a different perspective on the data. And the where condition is where we use that selection criteria to satisfy the condition, right? So this is where we decide what it is about our tuples that we want to, whittle down the data by and apply that here. So let's look at some examples using a schema that I think will be helpful with your projects. So the first thing I'm going to do is we have a client relation here, and this one's very simple for now, and I'm not implying that these relations in any way are like all you need for the project. In fact, user should tell you right away that's not true, because you have like a detailed spec on user, and this doesn't have almost any of that stuff. But it is a good place to start, and I like using it because hopefully it will help you in the project as you're building your own relations and trying to understand them. So I try to keep using, when I can, any examples from the project. The book has a completely different set of examples, and that's good, so it also gives you a separate perspective. So client is simple. It just has an ID referring to the client ID and the name of the client. The user has an ID. It has a reference to the client ID. Now, in normalization, you're probably already picking up that this is going to be a one-to-many relation, and I'm not advocating that it should be. In fact, we're going to see some kind of problems with this approach in a little bit. So I'm not advocating that you have a one-to-many relationship between your user and your client. Will it work? Probably. Is it the best solution? I don't know. There's also a first name, last name. Both of those are varchar text type fields. There's an email address, which is the same, and the user's age is stored. I believe that's an integer. The role table has an ID for the actual role ID, say like admin, client admin. I think there was omni admin, client user, those kinds of things. So those would all be tuples in this row table. So the name of the role, which is kind of like those ones I was just describing, and a description where you could put more text about the role to describe it better. The user role now is obviously probably going to be a many-to-many relationship between user and role, right? So we can kind of see that because it has a user ID and a role ID. Now, I opted here not to have a compound key for my own reasons of laziness, and I have a primary key of just an ID, which is unique to user role. Again, I'm not advocating that that is the correct, most correct solution for this relation. I'll leave that up to you to decide. It's definitely a solution, and having user ID and role ID combined into a composite key also would have been a solution. So you guys can pick. In fact, user role, you would make an argument here that in fact it could be user ID, role ID, and client ID as a composite maybe. But again, I'll leave that up to you guys to decide. And active is just what it sounds like. Is this an active role? So in other words, if I applied the role to Johnny, and that would be active might be a 1 for like a Boolean on, and if I one day take the role away from Johnny, maybe instead of deleting the row, I just turn active to 0. Now, of course, your business logic has to deal with that correctly, right? When it's doing the role checks, you have to know to look for that. So I'll leave it to you how you want to deal with that, but I just wanted to explain what active is in this context. So basic selection looks something like this. If I select everything from my user table, where first name equals Brian and last name equals Gormanley. What I'm showing up there is an original relation with 3 tuples where I do have a Brian Gormanley, I have a Jane and 2 Jane Does, and if I run this query on that relation at the top, I'm going to end up with what we have at the bottom, right? So it's just the one tuple that matches where first name equals Brian and last name equals Gormanley. Now remember, Boolean logic applies, so and means both of these things have to be true in order to return the tuple. If I had a tuple where it was like, you know, Brian Gorman but no Lee, because I was specific about Gormanley, that tuple would not have shown up, right? Only one that explicitly matches the text that I have there. Notice that unlike most programming languages, this is a single equals. So for those of you who have been programming a while, you're probably like, that's assignment, right? No, not in SQL. That's not assignment. That's comparison. So you know, just keep that in mind. It's one of those, you know, gotcha if you're going back and forth things. But this is pretty straightforward. So this is how I would grab, you know, say one row there. If I wanted to say get rows where first name equals Jane and then just leave off the and last name part completely, it would return 2 rows, right? It would return the second and third ID'd rows there. So there's 3 kind of ways that we break this down. So I just want to look at what's happening under the covers here. The first thing that the database management system actually does when it reads this piece of SQL is that it gets with whatever relations are in the from clause. Now for right now we only have one, so that's user. So it goes to that relation, which is at the top of our screen here, and it grabs the whole thing. Right. The next thing that it does is it applies the selection that's in the where clause. So that where first name equals Brian and last name equals Gormanley basically iterates through each one of the tuples, applies this, you can think of it as like applying an if statement, and if the conditions are true, then it keeps that tuple. The last thing that it does is then apply the projection indicated in the select clause. So if we go back up here, our select clause projection is just star, so that means that all of our attributes are going to come down, and they do. But if I had, say, select just first name from user, the only thing that would have been returned here on the bottom would just be the first name attributes of the tuples that match the where clause from the user relation, right? So I'm just kind of working that out the other way. So those are the 3 things that matter when you do a select. Now, here's an example of that limited projection. So if I want to just get first name and last name, same idea. I've changed the where clause though here, notice. So I get user, so I get all 3 of those tuples at the top. And then I apply where client ID equals 1. So if we look there, we can see there are 2 tuples at the top, IDs 1 and 2, that have a client ID of 1. So Brian and one of the Jane rows. And now I'm going to, on that, project first name and last name. So now I'm eliminating columns. I'm eliminating those attributes that I don't care about, and I'm only keeping first name and last name. So that returns my name and Jane's. Now, while I'm on this topic, just a quick aside, we talked about client ID before and whether a one-to-many is a good idea here. So what this is actually showing here, and there's kind of evolutions of this that we'll see throughout the slides today, is that Jane is actually in here twice, right? And you're like, well, wait, why is Jane in here twice? That's not good normal form. And it's not, right? Like, what if I update Jane's name or something like that? You know, how do I find her in the other rows? Hint, hint, hint. But why is this happening? Well, I have a one-to-many relationship, and Jane, unlike me, is affiliated with 2 different clients. So the way that this is set up right now, I have to have a row for Jane's information twice, one for each client. And what this means is if she updates her name, say with client 2, will it be updated in client 1, right? Or her email or something like that. So just something else to consider there. Another thing that those who are like eagle-eyed, astute, like, what are you doing? I have a computed field here, and I do. I just wanted to get some fields in here that were easy to manage for the demo. But for those of you who astutely pointed out that age is a computed field, and I should instead just be keeping birth date and figuring age out dynamically based on birth date, you are absolutely correct. So for those of you who have noticed that, good catch. All right, so let's now talk about renaming. So we know how to project. Let's see how we can also use this as keyword to kind of project differently. So we want to now have that same select idea, but we're going to have first name, and then we're going to use the as keyword here as FN and last name as LN. And basically all that does is return what you're looking at. It changes this here from the standard first name, last name to FN or LN or whatever we decided to call it. Now, this will be more important when we start bringing in more than one relation. We'll look at that in a moment, but when you start joining, sometimes relations have attribute names that overlap. So for example, ID, right? You might have an ID field in every single relation that you use. So how do you differentiate the first one and the second one, so to speak? And we'll look at that more as we do it. But for now, I just wanted to get you kind of used to the idea of what the as keyword is. We're going to see more of it as we keep going. The next is that we can put expressions in the select clause. So you might have seen this before if you've ever worked with SQL a little bit. This is another reason why I had age in there. It was kind of a lame excuse to give myself a number to double. That wasn't like an ID or something. But what we're doing here is we have user, right? That same relation we had before. We're doing a select on it. And we're returning first name, last name, and age times 2. So we're taking age and we're multiplying it by 2, and then we're putting it in a field that we're calling double age, right? So you can see I ended up with first name, last name, and double age. So you can put little mathematical expressions up there. You can put min and max and other things. We're going to talk more about that later. We don't dive deep into that here. I just wanted to explain for now that you can do expressions here. And you will be as you go further, I'm sure. So here we're combining that with the renaming of the attribute to double age. The other thing we can do is put a constant up there. Now, this, I'll get into why this is useful more in a moment, but here we just have our user relation, and we're projecting from that first name, and kind of the static is awesome, just to like say everybody in the user relation is awesome, which is cool, especially since I'm in there. But one thing I just want to add here is like one place this is common to do is when you're doing some kind of data warehousing where you're combining multiple data stores. So if you're writing queries on top of queries, so to speak, you might write one query on top of like a single database that's like an ERP system for a school or something, right? And then you might have another database, well, not really a database, but some other data mining system using that query, taking its results and inserting it into its own select statement. Or you might be assuming that because it already ran some function call or API call to get data from that system, and you know you were limiting it by, say, awesome people, when you do the select off the second database that you're going to do, you can just insert a static field there is awesome, because you know that the results you're using to generate that query came from a first data store that returned only awesome people, right? So this is one of those ones that you don't use it all the time, but it's good to know it's there. So you can put static stuff there or constants in the select. There's more. Here's the rest of the kind of comparators we can use and the where. So right now we've just been using the Boolean really and, but I didn't really talk through or not, but you can use those, of course. So, I could have done where first name equals Brian or last name equals Doe, and that would have returned both me and Jane, right? Because her last name is Doe and my first name is Brian. You can also do not. I can, return everything where first name is not Jane, and that would have returned Brian, right? You can also do comparisons. So comparisons, the Greater than, less than, like that is a not, so it's basically not equal. And then you have obviously less than, you have greater than, you have less than or equal, and greater than or equal. And those are exactly what they sound like. There's no difference there than any other programming language. The only difference is the not equal is commonly like the bang or the exclamation mark equal in most other programming languages, not the less than, greater than. But that's just, again, another deviation here, not a big deal. So we also now can use these. Here's an example down here. Select star from user where first name equals Brian and last name equals Gorman. I guess that's the same example I had before. Sorry about that. So that's just using that as a remember of what we did. There's more ways that we can use in the where clause to limit the amount of tuples we come in. There's patterns. We're going to use like a lot later. Like is a way to say that, I want this to match a kind of portion of this. So you use like with either a percent sign or an underscore. A percent sign represents basically what I would call splat, or any number of random, and not random, but any number of characters can be anything. So what I mean by that is, like, let's say you wanted to search for everyone who had a first name that started with B, right? You could say in the where clause, you could say where first name like, and then you would have the quotes, the percent sign, or you'd have the B first, sorry, because it starts with B. So you'd have the B, then you'd have a percent sign after the B, and then you close the quotes. And that way, any first name that starts with B will satisfy that condition. If I had done B underscore, it would have only worked for 2-character first names that have a first letter of B, right? So that's an important differentiation between the percent sign and the underscore. The underscore only is a wild card for 1 character. The percent sign is a wild card for any number of characters that follow or precede, depending on where you put the percent sign, what you want. So a common way to do this is, like, you're looking for, like, say a search. This is a really common query for a search string. So, let's say you're doing a search for your site and your site is stored in a database, and you would have a query, something like, search all of the text in the database where the text is percent, whatever the search string is, percent. And then it'll basically return anything in that database, any row that has an attribute that has that search string in it. That's a very, very common place that you'll see that pattern. So here is an example of that. I should have came to this as I was talking through it. Sorry about that. But basically, select star from user here, where first name is like B%. So that's the exact same example I was given before. And last name is like G%. This would return me because my first name starts with a B and my last name starts with a G, right? It would not return Jane because she's J and D respectively. Null values. So we haven't really spent a whole lot of time talking about null here, but this is an appropriate time to do it, because once you start bringing queries into the picture, you have to effectively deal with null. So tuples in SQL relations can have null as a value for one or more components. And what this basically means is that, if I have, say, like an email field and I don't make that field not null, meaning that it can't be empty, and I don't have business logic like my program enforcing that the user can't save it, it is possible, and maybe you want it this way, that a person's record could be saved without an email address, right? So, you could have an insert statement that inserted my first name, my last name, my age, but no email address. And when that happens, a null is what will be put into that attribute in that tuple, right? So that component will be null. Now, that's the first use case of this. It's a missing value, but you could also think of it as being inapplicable, right? So it could be missing, or it could just be that, like, if you had a spouse field, again, is this normalized? I don't know. Well, that's further discussion later. But if you had a spouse field, on a person's record and I'm not married, then obviously I don't have a spouse, right? Now, one of the reasons you normalize, remember, is possibly to remove null values. So you could make the argument that if the table was properly normalized, this wouldn't be a problem. But you're always, I think, going to have cases where it is normalized to say, like, I don't have multiple email addresses. I only ever store one. It doesn't really make sense to have an email table with a one-to-one relationship with a user other than to remove a null, right? So that would be, at that point, that would be what the purpose of having that separated table is. Because if I don't have an email address, then I don't have to have any rows in the email table. But if I do have the email address in the user table and I don't have one, then it's a null, right? Now, nulls happen. They happen a lot. But what's important to know for us is that they are their own beast when it comes to doing comparisons. So like before, when we were looking for first names and last names, and I was using that as an example, null is going to throw a wrench in this. Anytime you have an attribute in the selection, so meaning like in the where clause there, what you're deciding to select the tuples by, nulls will not come up the same way as a true or a false, because they're a different thing. It's actually an unknown. It's not the same as a false, and it's not the same as a true. It's actually its own thing. So the easiest way to kind of like look at this is to expand our example a little bit. In this one, I changed my age to null because as much as I wish to be 21, that's not really true. And we're just going to say I didn't want to give it because I don't have to. So I don't have an age there. But if you do a select and age is the criteria, that is our selection criteria, then it might yield results that don't necessarily make sense. So first off, if I forget the or part of this, if I had said where age is less than 20, no one would have showed up, right? Because I'm null, Jane's 51, and Bob is 112. So that's fine. We kind of expect that. If you had done the other way, again, ignoring the or, but just where age is greater than or equal to 20, you would have got Jane and Bob, but again, you would not see Brian. But interestingly, when you combine these things, you would think, hey, I'm covering the whole gamut here, right? I have age is less than 20, I have age is greater than or equal to 20, I've covered every single number. Well, yes, but null is not empty, or null is not false, rather. Null is just unknown. It's a different thing. It doesn't come up under these queries. You have to specify or is null or is not null. So that's what this is. So if I expand this query here and I say select star from user where age is less than 20 or age is greater than or equal to 20 or age is null, now I've included my record. You can also use is not null if you want to return things that are only not null. So you could use that as like, it's actually a very common where criteria on your selection, just to kind of eliminate those null values to make sure you don't get them. But it is important to note that anytime you're dealing with nulls, your queries have to accommodate for that where they need to. If your fields are not nullable, meaning you've created them with a criteria that says I don't allow null in this field, then it's not a problem because you won't have null in the field. The database management system won't allow you to insert it. But if that's not the case, something to consider when you're creating your database, what fields should be nullable and what ones shouldn't. Most people, they don't necessarily give that a lot of thought, or they let the business logic of the application handle it, meaning, whatever form I fill out enforces that I have to fill out my age. And the assumption then is that I'll always have an age because the enforcement was done at the application level. Maybe that's okay for you, but I think database administrators might argue that, if you intend for that thing to exist, then that field should be labeled not null, because then the application can't mess up, or if it does, it doesn't save the data. But that is how we deal with making sure that we can query when null is involved. So now that we got through, that's all the basic stuff for queries. Now we're going to move on to multi-relation queries. So these queries aren't all that interesting so far, right? Like, getting myself back from a user table. I mean, it's good. We need to know that stuff, but most of the queries you write are going to involve more than one relation. That's just the case. So this is where things get interesting and also powerful, because one of the things that sets a relational database apart from most of its competition, so to speak, as far as NoSQL, is that your power to just query any which way you want is really, really, really high. You can invent new ways to imagine and use your data using a relational database very easily just by inventing new queries. So every time some new business requirement comes up years after you've created the database, you're not left out in the cold. It's not like you have to go find a new development team and dust off the docs and rebuild everything, gear everything up for construction because, I just have to write a query. No, you can just create reports on the fly, and you can do so very easily because of this kind of superpower. So this is one thing that most NoSQL systems do not do, at least not with the same elegance, mostly because you're building the relations based on the queries and not pure relational form. Building on pure relational form is what gives us this kind of superpower. So with all that said, we're just going to, for now, we're going to see the renaming part. But you're going to see that we describe multiple relations with the relation.attribute syntax. So, if I'm, say, talking about, say, the ID field in the user table versus the ID field in the role table, it would be user.id and role.id, respectively, right? So the simplest way to do this, now we're going to talk about, the right way and stuff later with the join on clause, but for right now, we're going to talk about the older comma, which is also very commonly seen, the old comma syntax where in the from clause, and that's what we're going to start with. So we'll show that first. The first two relations I'm going to work with for the examples are these two. So these are more evolved right out of something that could be used for our project. So this specific problem that we're dealing with is the username, the user and the ID, right? Because we said that one of the criteria is that you have to be able to scan the person's ID. So that's actually what we're looking at here. Now in this, again, this is not implying correct anything, right? I think we talked about that when I laid out the project, that one of your design problems is to kind of decide how this should be done. This is just one example, it's one possibility, not intended to imply correctness or anything like that. So if yours is different than mine and you've already got this far and you're like, no, but I like mine better, that's good, stay with it. We're going to talk about possible problems here as we go through it. So I have 4 records in my user table here. Notice that they all have a client ID as before. I've added Bob there. And I have a password field now so they can log in. I have a map name. What this is by the way, I'm Vin Diesel. It's a long story. The map name is basically when your little dot is moving around the map, for when somebody's looking at the map and they see all the people moving around, that's the label that they'll see for the person. So if I'm on the map, they'll see Vin Diesel walking around, which is pretty cool. And if Jane's on the map, it'll just say Jane because Jane's cool too. And Bob will be Bob, and that's fine. But that's all that is. So map name is not like the name of your home map or something like that. It's actually the name of what you appear to be on the map. And I think the rest of this is pretty straightforward. Oh, color isn't. So color is also when you get your little bullseye dot or whatever graphical thing represents you on the map. Again, you're not going to be building any of that because you guys aren't building the actual software. the color is just what color that dot is. So, you know, if you have all these people on the map at the same time, it helps if they all have their own color. So, you know, mine is null, which is interesting. That would probably break something. Jane is red, and Jane's other client account is green, and Bob is blue, right? Because FF in the first set, it's red, green, blue. So FF is pure red, 00FF is pure green, and 0000FF is pure blue. Active just means like, is this user account active? Kind of like what we were talking about with role. Then we have the ID. So the ID relation here has a license number. This is intended to be a made up number like you would have on your New York State or whatever state driver's license. Your user ID relates, it's really a one-to-one obviously here, but technically it could be a one-to-many. This is one of the things I left open for you guys to figure out how you wanted to deal with this, because technically, I guess it could have more than one ID, right? Like I could use my New York State driver's license and then maybe I use a passport or something, right? And the tricky part here is I gave this field the name license number, which kind of implies that it's a license, like a driver's license instead of a passport. It's a bit of semantics, but it is possible that I could have more than one ID issued, right? I could have, and I do, I mean, I have a passport, I have a New York State driver's license, right? Maybe our system wants to account for that and to draw both of those things to me. So in that case, it's a one-to-many, which it would work, right? I could have a different number and a different user ID. Now, it's important to note, though, that because of that, the primary key for this is the combination of the two, right? Because hypothetically, I guess that's the proper way to do it. Hypothetically, there shouldn't be a repeat of a passport ID or a license ID, so that inherently should be enough. But in this case, I would prefer to do it with the combination of the two, because license number is not a made-up thing, right? So gender is straightforward, eye color is straightforward, DOB is date of birth. All right, so let's look at our very first selection with two relations here. So we have select u.first name. I'm going to get to the u dot in a moment, but as I talked about before, we're going to have new use for our as keyword, u.last name, id.gender, and id.eye color. And then if we go down to our from, remember this is the first thing that the database management system does, is what's in the from. It grabs those relations, right? So it takes the entire set of user, the entire set of ID detail. Notice now that we're using the as keyword, so we're relabeling the relations u and ID. It's going to make them shorter, but it also helps us differentiate as we're doing our where clause what attributes are from where. So you want to do this. Most database management systems will allow you to kind of duck it if there's no overlap in relation or in attribute names, but I don't recommend that. I recommend as soon as you're using more than one relation to just give the relations an as name and then use the syntax of relation dot attribute. You could of course skip the as and just do the full name of the relation dot attribute, and that's fine. It's just a lot more typing. So I'm doing this for succinctness and because I'm lazy, and yes. So we have both relations now, and they have new names for them, u and id. And then we're going to do our selection, and there's two parts to our selection. The first is we're only going to return rows, this is important, where u.id equals id.userid. So this is where we're doing this join, right? This is where we're looking here to say, like, I don't want, because if you return both of them, you're actually going to get like basically two rows for each person. You're going to get this kind of mesh of all of it. There's not going to be any relatable way to bring them together. So this is what's actually known as an inner join, where you're only getting the intersection of the two things, and we'll talk more about the specifics of that later. And then on top of that, we only want the rows where client ID equals 1. So this is essentially going to throw away Jane's other row, the one that was from client ID 2. If we go back here, so row 3 here will not be part of these results. Row 1, 2, and 4 will, and we'll tie in here. Basically, it's going to look at this and it's going to say, okay, well, I'm joining on that. I'm joining 1 to 1, 1 to 1, 2 to 2, 3 to 3, and 4 to 4. And then it's going to throw this one away with this one because those are related to client ID 2. And then it's going to return what we see here. So you have first name and last name from the user table, gender and eye color from the ID detail table. So that's how that works, and we're going to see some more examples of it as we go through. Again, the semantics is the same, right? It's good enough to kind of just go through one more time. The from clause is where we start. We get both of those relations. We apply the selection that we see down here in the where clause. So we're joining them just like I described before on that ID and the user ID. And then we're also, in this case, we have another clause that eliminates anything that doesn't have client ID 1, right? And then from there, we do the attribute projection. So we take those rows that were returned and we use projection to eliminate the columns that we don't want, right? So we're going to have just the u.first name, the u.last name, the id.gender, and the id.eye color. And that's how we end up with our result. So now we're going to talk a little bit about how we can kind of nest queries inside of queries. Now, there's some cool debate on this and when you should use it and when you can and performance things. And I'm going to just kind of allude to a little bit, but this is going to also work to what we were talking about before with query optimization. So there is some interesting pieces to this. So we'll get into that in a moment. The parenthesized select from where statement is how we're going to do it. Basically, we're going to say, okay, I want to have a query inside a query. And the way that I know I'm entering the subquery is that it's going to be in parentheses. That's pretty much it. You can put it all kinds of places, select, from, where, all kinds of places. And we're going to actually look at all three. So we'll look at examples of all of these. And the idea here is that it's another way to pull in new sets of data that will affect the ultimate set that we're trying to create based upon our query, right? So this is going to add a little bit of mental complexity as we look at it. The easiest way is to just kind of do it. So let's dive in. So we're going to take the first example here, which is the subquery in the select. So here I'm using my user relation again, and I have one. I'm going to try to do it in the order the machine does, right? So I'm down here. So I have from user, and I'm going to use a selection of client ID 1. So we were using that before, right? We just don't have, notice we don't have the join condition yet here. We have it up there, which is a weird place to put it, but we'll get to that. But this is essentially the same except for that, right? So we're still going to return those 3 rows from our user relation. And then we're going to project ID, first name, and last name. And then we're going to also project another query's result. So this internal query now is also going to query from the ID detail, right? Notice that there's no reference to ID detail in the outer query. It's only in this inner one here. So this is going to select the ID detail relation. It's going to select, by picking the rows where the user ID equals the user ID in the current here, right? So as I'm returning the tuple from the first selection, I'm using that tuple ID attribute in this second. So it's literally running a query inside a query, right? So I got the results of my first query, which is the 3 rows. As I go through them, because I limited by client ID 1, as I go through them, I run a query on ID detail where the user ID equals the ID and the current return tuple. And then I return from that, I use projection to only give me back gender. And because it's one attribute, that nicely just comes back, right? So the result is the same. I get ID, first name, last name, and gender. I added ID because I was using it over here in this selection, so it's also showing here. So this is a different way to do this, right? It's achieving the same result. Is it better? I don't know. We'll kind of explore that more in a moment. Now let's look at a from example. So this is kind of achieving something very similar again. Here we have in our from, so we have from user as you, and then we have a subselect. So we're actually, instead of giving it the whole relation, we're actually going to, at this point, like step one, we have user. Okay, so imagine that in memory is now your user relation. And then we have this select that's going to generate a relation, right? And we're going to use those two things to do the selection and projection for the main query. So in our subselect here, we have a select gender user ID from ID detail. So it's going to start by grabbing ID detail. It's then, going to select where gender equals just male. So it's only going to return the rows Brian and Bob. And it's going to return gender and user ID as the projection from that. And now that's what I'm going to have there. I'm going to have this, it's almost like a view. We're going to talk more about views in the future, but a view is kind of a maybe a subset or a composite of other relations. It's a temporary relation in memory, right? So that's what this is. It's now a temporary relation in memory. We have this subset of ID detail that only has gender male and the projection gender and user ID. And that's the relation that's in memory that we're going to use for this other outer query, right? So now the outer query has that in user, and from those things, it's still going to join user ID on g.userid, which is that subselect returned. And then we're also still going to do u.clientID1, which I don't think we needed to because that's superfluous, because the only one who was in client ID 2 was Jane. And she's not here anyway because she's not male. So she was already eliminated. But, imagine there was other rows and we still cared about that. And then from all of this, we're now going to project that we want the user relations ID, first name and last name to show. And that's what shows here. Notice I don't even put the gender on here, right? As far as the results, they're just eliminated if they're not male, right? So it's honestly kind of convoluted. I wouldn't naturally want to write a query this way, and there's some good reason not to. So, or at least, and not in every situation. So it's tricky. I can't make a blanket statement. I can't say that subselects are always worse performing than not using them, right? Than just doing a straight join. That's not always true. In fact, in this case, it is, and I'm showing that here, at least in MySQL, but it doesn't mean that it's going to be true in other database management systems and under other circumstances with other data. You really, really, really have to optimize, like we were talking before, for your own database system using your own queries on your own data. So in this example, the subselect is worse. So what I did here was I set the profiler in MySQL. I'm going to include you'll see the commands for that in the text I put of the dump. But essentially here it just shows that the first query is the standard join that we were using before. And it was done in 0.000249 seconds. And then the one with the subselect in the from clause was a little bit more than double the amount of time, right? This is very small amounts of data, but it was 0.00055, right? But imagine that you have, millions of rows, right? So if that's true and it's double as long, that's significant, right? So you have to take this stuff into account when you're actually building your working database management system and the software on top. You have to know, how long do these queries take? Querying your database is like one of the first places you should look if you're having performance problems with your application, because it's I/O, right? It's technically going to disk, and hopefully it's got some caching and some other mechanisms to speed things up. But this is definitely an opportunity to, in this case, double the speed of a particular query just in how we wrote it. The results are the same. So there's no golden rule that says subqueries are always you know, slower or something like that. There just isn't. If I were to say that it's probably more common that subqueries perform worse, I think that would be a true statement than, say, a query that does not include the subquery. But it does not always make it true, and that's very important. You have to optimize for your individual things. So here's one in the where example that's actually a good example of that. So this one we have the third type we have in the where, so we're just using user here. So the first part of this is the from user. It returns the user relation. And now in the selection piece, I'm actually going to select ID is in. Remember we talked about in as being kind of, you know, is this thing in a set? We looked at it when we looked at, you know, using the wildcards. Now we're going to have like where ID matches rows returned from this subselection. So the subselection, let's now look at that as ID details. So that's a relation we're working with. Our selection is going to be where gender equals male. So that's going to eliminate the ID rows that don't have a male gender. And then we're going to have as a projection, all we care about, all we want to return is the user ID of those rows, because that's what we're going to match to the ID coming from user, right? So effectively we're accomplishing, again, the same thing. We're just doing it in a different way. And now we're projecting on the original query that we want the ID, first name, and last name. So that will return, obviously, just the ID, first name, and last name, just like it did back here for Bob and I. This, what it's showing here, is actually the result of this subselection. So this here results in this 1 and 4, and then this, where it says where ID in, it's saying where the ID for this is in this set, which is 1 and 4. So the ultimate thing this is going to return is this, but what it's showing here is what the result of this inner query is. Now in this case, right, where we look at this, ironically, this, the one that we're looking at now, is faster, right? So this is why I said you can't always take this verbatim. You have to test, and who the hell knows? With the data this small, it's absolutely impossible to know for sure. Like my operating system could have interrupted the database engine and said, you know, something else has got to run. I got to update the time or something on one of these, and it didn't on the other, right? So with this amount of data, it's so minuscule. There's no, this is not to say like this way is right and this way is wrong. It's just to show that you have to test this stuff with your own data and your own system. In this case, it was like a third as 3 times faster to do the where in. Now, I don't know if that's legit, but that's the result I got. If I had 1 million rows in here, we could have run this, you know, and actually gotten a little bit more out of it. You can run it multiple times and make sure it's just not a fluke. But, you know, there it is. So in this case, it was 3 times faster to do the subselect in the where. Now, not saying that you're going to always get that result, but in this case, I did. Okay, so the in operator. So we have been using this now a couple of times just to kind of make sure we give it a good, strong definition of its own. The in will return true, meaning like I will return this tuple in the selection if and only if it's a member of the relation produced in the subquery, right? So we saw that before over here. If we looked here, we had the 1 and the 4 here returned in our user ID subquery return. So if the tuple in the main query has the ID in that set, then it's returned, right? You can also use not in, which is the opposite. That would have returned Jane, right? So you can use the opposite of in, which is not in, and that will flip to the other. Another example, or another way we could do this is exists. So we could, I don't have like a whole query written out here, but I just want to point out the difference here. So exists is true as soon as, so the way it's worded here is a little bit harder to follow, but basically the way it's worded here is obviously it's true if the subquery result is not empty. So what it really means by that is the second bullet. As soon as it returns a result, it's true. So if this can actually be lightning fast. If you only need to know that something exists in one relation, the moment it's found to exist, I don't care if it exists a million times, the moment it's found to exist, it returns it, right? So this can actually be really, really fast in comparison with in. In is very meticulous. It goes through the whole thing. It'll iterate through and find every single tuple in there and list them all out. Exist just says, does this thing I'm looking for exist in this other thing? And if it does, cool, I'm good. So this is a little bit faster, especially where we just need to check for the existence of a record. We don't need to count them, right? If we don't care how many there are, exists is probably going to be a better solution for us. Another alternative is any. So any is very similar in many ways. So basically, any is the condition is true if X, which is whatever we're comparing to the subquery that's wrapped in any, equals at least one tuple of the subquery result. So this is very similar in some ways to exists. It's a little bit of semantic sugar. The syntax is different. You can see here that it's, the X greater than or equal to instead of the exists in. Or exists, sorry, it's not exists in. It's really just, these are kind of just semantically different. It's not really all that different in practice. All is again similar, but this one does actually return different results. So this one is true if, and that's only supposed to have one F, for every tuple in the relation X is not equal to T. So what you could do with this, an example of this would be here. I think I have one. Oh, no, that's joined. I guess I have it down here. So in this example down here, you could say that there's no tuple larger than X in the subquery result because we're looking for X is greater than or equal to all in the subquery. So meaning that you're only going to return X if no tuple is larger, right, than X, because you said a greater than or all, equal to all, right? It's just a different way to get results. You can play with these in all different kind of combinations to find exactly what you're looking for. Are you looking for, like, is there, any login time that's newer than this or older than this or that kind of thing? So these all give you different ways to get to that same result. Remember too that the less than greater than combined can be used to say, not in, right? All right, so let's move on to joins. So the modern join syntax, what I've been using up to here, I called the comma from, like the from comma syntax. The modern join syntax is slightly different for inner joins, and then we're going to talk about outer joins beyond this. So instead of saying in the from, I have one relation comma another, and then in the where, picking the condition on which they join. Instead, this is a little bit more elegant and more explicit a way to say it. We're gonna say R joins S, meaning, relation 1 joins relation 2 on, and the condition in which they join. So in this example, we have select u.firstname, which we know is user.firstname, u.lastname, id.gender, id.eyecolor. This is going back to that very first one that we had. From user as u, join id details as id. So again, we're taking what used to be partially in the from clause with the user and ID detail and the as part, those were there too. And then after as, this part was in the where clause before after on, u.id equals id.user ID. So we're kind of more eloquently putting everything to have to do with the join together. We're not splitting it into the two areas like we were before. And then the where clause can be specific for the criteria that is actually going to do the selection, right? Not the join. So you can see the difference there. I put them side by side and you can kind of compare them top to bottom. This is an example of what's called an inner join. So as we go forward now with the different join types, I just want you to know that when you hear, like the inner join, we're referring to the same classic join that we were working with when we did the comma syntax, right? So it's the same as a plain join. An outer join is a little bit different. So the way an outer join works, I'm going to walk through these, and this way you can kind of come back to this part, maybe like bookmark the time in your head or something when you're doing any queries that you need to kind of consider this part. The outer join allows you to not only match the rows between them, the intersection, but also to bring in data say from one side or the other, or even possibly both, although the full outer join isn't something that is commonly used. I don't even think MySQL really still supports it. Other DBMSs, I'm not sure, but it's not as commonly used. So a left outer join, for example, would be, like say I'm joining a roles and, or let me start with users. So table 1 in that graphic up there would be users, and table 2 would be roles, right? So a left outer join would basically include in the return all the data from the users table and the intersection of the user and the roles table, but not necessarily the rest in the roles table. And then conversely, the right outer join, that would return the intersection of the users and the roles and the information in the roles table, right? But not necessarily the information in the users table. So that's the difference there on how the outer join and the inner join work. The inner join is just the intersection. The outer join is a little bit of kind of difference on how the DBMS actually returns the data after it figures out the intersection. It will return, basically the first table or the second table, depending on it's a left or right join, along with the intersection, right? So that's effectively what these things are. So another way of phrasing it, left outer join returns all records from the left table and the matched, which is the intersection, from the right table. Right outer join returns all records from the right table. So just remember the left and the right. It's, just think of it first, second, left being first, and the matched records from the left. The full outer join is going to return this all. Again, this is not a commonly used thing. Just know the definition of it. I don't expect that you'd be using it here. So that's really it. We've actually come full circle on everything that we wanted to touch on for this. We're going to have a lot more with SQL when we get into the advanced section coming up, but that's after the midterm in the next section. So good luck on your projects, and make sure, like, if you're having any trouble with any of this, get to me and let me know. I know not everyone comes into this course with the same amount of prior database experience, and that's one of those things that I definitely want to help if you haven't had another database course in your past or any extensive experience. It can be a little bit much to even just get a database management system up and running on your computer and to be comfortable with using it. So please do reach out to me if you're having any trouble with that. As I mentioned, I'm going to put up as a separate text file all of the queries that I used in here so that you can play along with them. And I really, really, really recommend that you do that. Please find that file. If you're not using MySQL, you're using whatever else, doesn't matter. Just make sure that you're comfortable running those queries in your own system. I have the little create scripts in there so you can actually create the tables that I used. Just do it and make sure you're comfortable with it, because as long as you can do that, then everything in the project is really just your design prowess, right? Which is what I want to see, because you have all the pieces together you need. We know how to make the ER diagrams. We know how to do the higher level design. We know now how to make the SQL, and we had the create SQL from a while back, and now you know the queries as well. So I will see you soon in our next section.